So, Mike, tell us a little bit about yourself, how long you've been in the industry, and what you plan on doing today.
My name is Mike Kovac, the owner of Kovac Mechanical. I've been in the industry since '97. Today we're going to do a startup commissioning in DigiMEP.
Walk us through the first steps when filling out DigiMEP.
You got to pick the right form. Today we're using the DT HVAC Retrofit CX diagnostic form. And you need to put all the information for the store in, and it takes your GPS to prove that you were at the store.
Before we get started taking the performance measurements, tell us a little bit about the instruments you're using today, and what measurements will you be taking?
First, you need a good pipe clamp for your temperature and a meter that will read the pipe clamp. Of course, you need a manometer. I use a dual port because it gives me real-time readings for both of them, and that's for your static pressure and your TESP. Then you've got a digital optical tachometer, so you can do your RPM of your blower motor and blower wheel to make sure that your speed is set properly on the blower motor.
What have you done so far, and how long did it take you?
Initially, when you get into the form, you have to get model number, unit information, all the refrigerant statistics off of the nameplate. You got to get your disconnect information, take pictures of the unit, and just fill in all of the unit information correctly so that the system knows what you're working with before you start taking your measurements.
And how long did it take you to complete that?
From 5 to 10 minutes, depending on conditions and how long you've been doing it. You can work a lot faster once you're used to doing the program, as opposed to the first time you're doing it, it's going to take you a little bit longer. But once you're into it and running through the program, knowing how it works and what it expects, 5 minutes to get everything set up.
Now that you've collected the model and equipment information, what are the next steps?
Walk around the unit, get a feel for basically quality control on the installation, make sure everything's the way it's supposed to be. For example, we can take a walk over here. It asks to take pictures of your condensate line to make sure everything is right. So you walk over here, watch your head, and come around the unit. Take a look, condensate drain is in here. Make any notes on issues you might see, something that needs to be changed. Take your picture, put it into the system. We see that that drain needs to be ran out a little bit further, so you put no, and then put it in your notes what needs to be done to correct the issues. Then it asks what type of heat you have. So we come over. We've got natural gas heat. Meter sitting over there, so we select that. And then we get into the unit and check to make sure it has its drip leg. It does. Take a photo of the gas line. And it really just walks you right through everything you need to do.
What's next on DigiMEP?
We've gone through, taken the pictures of the unit, did our assessment of the installation quality, and now it's time to start taking some measurements. First on the list is gas pressure, and unfortunately this one does not have a tap to test the inlet pressure and the outlet pressure. So we're going to have to skip that and make a note. But you can always check your gas pressure at the meter if you've got a tap on it. The first thing I do when I'm checking out a unit is I always check the voltage. You should always make sure you're doing it safely with your meter. And on this unit, we're 210 volts. You always want to check your main transformer because it's multi-tap. If you don't have it set properly, you can cause all kinds of issues with these newer units. So you always want to make sure. This one is not set properly. This is set for 240 volt. You can look right in here and take a look. So what you want to do is go ahead and shut the unit power off and switch that over to the 208 volt side. Now, after you've checked your voltage, make sure everything is set up properly, especially your transformer, because of these new units. You want to go through and check all your connections, make sure all your power connections are correct. All of your terminals are set up for your EMS. Everything's wired correctly for your thermostat. So when you're on the form, it's going to take you step by step, as we said. Next on the list is taking some photos of the economizer and the economizer motor, damper motor, and all of that to show what we're working with. And then setting up the minimum position on the economizer to make sure that that's recorded in the software. Then we can move on to checking smoke detector and all that other stuff that's on here. They want a picture of the filters. And then there's a checklist that you go through for pre-startup as your voltage. Make sure all the materials from installing are cleaned up. Make sure that the outdoor air hood is installed properly on the economizer. All shipping bolts and everything have been removed from the unit. The flue hood is installed. Refrigerant piping checked for leaks. Make sure there's no oil. You just do a visual check on it. And this is all a checklist in the software. All the gas piping's been checked for leaks. Electrical connections are properly torqued. Gas pressure of the unit valve at the unit is within specs. The return air filter on the outside, make sure that's installed and it's clean. Making sure the unit's level. Blower wheels, everything spins properly. There's no wiring touching any of the copper, rubbing up against it. You never know, units in shipping. And make sure that the thermostat's running, and in this case we have EMS. Make sure that EMS knows that the unit's here, they're communicating, and they're seeing all their sensors. And this unit has crankcase heaters. You got to make sure that those have power going to them and they're running while the unit's off. Part of the process, checking the filters, making sure everything looks good. Give it a once over. First thing that catches my eye, there's a gap between the ductwork and the unit. That's why there's leaves on the filters. So that's something we need to address.
Where are we at now on the form?
We're about to start the unit up in cooling, bring it up to 100%.
Can Mike tell us about this step?
The form says what's the best way to get the unit running. In this case, we're going to jump the unit out and check that part on the form so we get the unit running up to 100%.
What other options are there in the form before jumping it out?
So have EMS, call up EMS and have them set the unit to 100%.
Excellent, thanks. Obviously, it's really important to circuit the system. So tell us how you determine what liquid line and what suction line go for each individual circuit compressor.
All right. For example, here's your hot gas discharge coming off the compressor. You follow it up to that section of the coil, and then we determine that this one on the top is our hot gas line. And we follow right off the compressor here to get that one right there. And there's your suction for that compressor.
Okay, and so where is the liquid line that the other clamp goes onto for the compressor? That's it right there?
Right.
That's the liquid header coming out of the condenser?
Yes, sir.
Excellent. All right. Why did you put the temperature probes on, run them out that hole, and then put the panel back on? What is that? What does that do for you?
This fan is pulling the air through the coil. If you have this door open, air is going to follow the path of least resistance, and all the air is going to come through here, and that coil is just going to get hotter and hotter because you're not pulling the air through the coil.
Now on the DigiMEP form, you're taking what temperature now?
The leaving air temperature of the condenser.
So what are you doing right now, Mike?
Checking the outside air temperature.
Where are you taking that temp?
About a third of the way up on the coil. gives you a good, accurate temperature because of that's where the air is coming through.
So that's what the coil sees.
Yes.
Yeah. Are you on the sunny or shady side of the unit?
Shady side.
What temp are you taking now?
Liquid line temperature.
Okay. And since you clamped on your clamps before the unit started up, how long does it take your meter to register the temp?
As soon as you plug it in.
You made an
it's been
instant
running
read.
for
Right.
about 10 minutes.
Yep.
We're about to take the static pressure readings, and I use this field piece that's got 2, so it'll give me the actual difference, your total static pressure. And when you're doing it, there's an arrow, and the arrow actually points into the airflow. I know most people think it points against the airflow, but that's not the way it is. You got to make sure that that arrow is pointing into the airflow, so these 2 tubes can pick up the proper static pressure reading.
Excellent. Okay, and then that's the supply. Where does the arrow point with the return?
Again,
Point toward the unit or toward the ductwork?
towards the ductwork, because
Yeah.
the airflow is going towards the unit. Right. So you want that tip to be in the airflow.
So in other words, a lot of people think that the arrow is the direction of air, but the arrow is the opposite of the direction of air. It points against the direction the air is flowing. Okay, into the air. Great. Okay, what are we doing? What are we inputting at this point?
We're doing the supply and return air temperature. So using the same holes, you use your probe to check your temperatures, let it sit for a couple minutes, and input your information.
So we're now dealing with the blower section. Tell us what your observations are and what measurement you're about to perform.
Okay. The first thing I notice is the motor pulley is still in the factory position, and this unit's been running, and the belt's already wearing out. It's a brand new unit, so we've got to make sure we've got the blower set up properly. So that's telling me that it's possible that we need to adjust this motor to spin this just right. So I've put reflective tape on here so we can use our optical tachometer to see how fast the blower wheel is going, and we're going to check that with the chart and see where we're at.
Mike, I noticed there's a VFD on the unit. So what do you have to do to make sure that the motor's at 100% so you can check the proper RPM?
You've got to jump out, make sure Y1 and Y2 are both jumped, and sending signal to the VFD to go to full speed.
Tell us what you're doing right now.
We're going to use the tachometer to check the RPM with the little piece of tape we put on. And we're running 856 RPMs right now.
Tell me what you just did.
We tightened the belt and adjusted it, and just a little bit. And now we're running 915 RPM. So we need to recheck our static pressure and look at the chart again to make sure where we're at.
Yes.